Hi everyone! I'm Donna Maybe Abejero.
My topic is about the momentum of photon and the Compton effects.
Despite photons having no mass, there has long been evidence that electromagnetic radiation carries momentum. Photon momentum is suggested by the photoelectric effect, where photons knock electrons out of the substance. A photon interacts as a unit in collisions or when absorbed, rather than as an extensive wave. Massive quanta, like electrons, also act like macroscopic particles. One of the best examples that shows macroscopic evidence of photon momentum is the tails of the Hale-Bopp comet point away from the sun, evidence that light has momentum. Dust emanating from the body of the comet forms this tail. Particles of dust are pushed away from the sun by light reflecting from them. The blue ionized gas tail is also produced by photons interacting with atoms in the comet material. Comet tails are composed of gases and dust evaporated from the body of the comet and ionization gas. The dust particles recoil away from the sun when photons scatter from them. Photons carry momentum in the direction of their motion, and some of this momentum is transferred to dust particles and collisions. Gas atoms and molecules in the blue tail are most affected by other particles of radiation, such as protons, electrons emanating from the sun, rather than by the momentum.
The Compton effect. The Compton effect is the name given the scattering of a photon by an electron. Energy and momentum are conserved, resulting in reduction of both for the scattered photon. It was coined after Arthur H. Compton. Around 1923, Compton observed that X-rays scattered from materials had a decreased energy and correctly analyzed this as being due to the scattering of photons from electrons. This phenomenon could be handled as a collision between two particles, a photon and an electron, at rest in the material. Energy and momentum are conserved in the collision. X-rays scattered from target containing every loosely bound electrons, in which we get the formula of momentum of photon, which is
H constant over wavelength of photon.
Let's have an example to prove that photons have a momentum. First, calculate the momentum of a visible photon that has a wavelength of 500 nanometer.
So in problem number 1, we have the formula of P is equal to constant and wavelength of photon, which is constant is equal to 6.63 times 10 raised to 34 joules per second. Then the wavelength of photon is 500 nanometer. We need to convert it to meter, so it will become 500 times 10 raised to 9 meter. So let us move on to the solution, which is photon is equal to the constant of 6.63 times 10 raised to 34 joules per second over 500 times 10 raised to 9 meter. So we know that joules is kilogram meter squared per second squared. So cancel the seconds, the meter, and we have the final answer of 1.33 times 10 raised to 27 kilogram meter per second. So this is the
Example number 2. Find the velocity of an electron having the same momentum.
In the second problem, we have the given photon, which is 1 times velocity. Since the velocity is missing, we need to derive the formula into velocity is equal to p over the mass. Then, we need to convert it. So, 1.33 times 10 raised to 27 kilogram meter per second over the 9.11 times 10 raised to 31 kilogram. And then cancel the kilogram. Then we have the solution. We have the final answer of 1,460 meter per second, which is approximately equal to 1,460 meter per second.
Example number 3. What is the energy of the electron and how does it compare with the energy of the photon?
In the third problem, we need to find first the first given is mass, which is 9.11 times 10 raised to 31 kilogram. We have the velocity, which is 1,455 meter per second. Then the missing is the kinetic energy of electron. So first, we need to find the kinetic energy of electron, which is, the formula is kinetic energy of electron 1/2 mass volume squared. So we need to derive it. So 1/2 times 9.11 times 10 raised to 31 kilogram times 1,455 meter per second squared. So the answer is 9.64 times 10 raised to 25 joules. So we need it to convert to electron volt, which is 1 electron volt is equal to 1.602 times 10 raised to 19 joules. So the answer for the kinetic energy of electron is 6.02 times 10 negative 6 electron volt. So next, we need to find the energy for photon. So photon is equal to energy to the speed of light over constant speed of light time divided to the wavelength of photon, which is equal to, convert it, 1,240 electron volt times nanometer. Then put the 500 nanometer, which is given earlier. So need to cancel the nanometer, and we have the 2.48 electron volt, which is about 5 orders of magnitude greater than electron of kinetic energy of electron.
Now let's move on to the relativistic photon momentum. Relativistic momentum is defined in such a way that the conservation of momentum will hold in all initial frames. There is a relationship between photon momentum, or P, and photon energy, E, that is consistent with the relation given previously for the relativistic total energy of a particle as energy squared is equal to squared of photon and speed of light plus squared of mass speed of light. Yet, P is equal to constant times speed of light over wavelength of photon divide constant of light is given you a constant over wavelength of photon. We know that mass is 0 for a photon, but P is not, so that the given formula before becomes E is equal to PC. To check the validity of this relation, note that energy is equal to constant
times speed of light over wave of photons, for a photon. Substituting this into photon is equal to energy over constant.
Another example is calculate the momentum of a photon having a wavelength of 2.50 micrometer.
In letter A problem, we have the wavelength of photon, which is the 2.50 micrometer, which is we need to convert it to meter, so it will become 2.5 times 10 raised to 6 meter. Then we have the constant of 6.63 times 10 raised to 34 joules per second. And the P is missing. So the formula for this is P is equal to constant over the wavelength of photon. So convert it, 6.63 times 10 raised to 34 joules per second over the 2.5 times 10 raised to 6 meter. So we know that joules is kilogram meter squared per second squared. So cancel. And we got the final answer of 2.652 times 10 raised to 28 kilogram meter per second. Next is letter B. Find the velocity of an electron having the same momentum. So for letter B, we have the given of P, which is equal to 2.65 times 10 raised to 28 kilogram meter per second. Then we have the mass of electron, which is 9.11 times 10 raised to negative 31 kilogram, which is constant again. Then we have to find the velocity. Since the formula is P is equal to mass times velocity, we need to derive it to find the velocity. So the formula will be velocity is equal to P over M. So we need to derive the given 2.65 times 10 raised to negative 28 kilogram meter per second over the 9.11 times 10 raised to negative 31 kilogram. So cancel the kilogram. Then the velocity is equal to 2.91 times 10 raised to 2 meter per second, or 291 meter per second.
And the last one is letter C. What is the kinetic energy of the electron and how does it compare with that of the photon?
In letter C, we need to find the kinetic energy of electron and the kinetic energy of photon, and also the ratio of these two. So let us first have the kinetic energy for electron. So let us perform this. So we have the mass of electron, which is 9.11 times 10 raised to 31 kilogram. And then we have the velocity of electron, which is 291 meter per second. So the formula is kinetic energy of electron is equal to 1/2 mass over 1 times velocity squared. So convert it, 1/2 times 9.11 times 10 negative 31 kilogram times 291 meter per second squared. So let's hang up there. So let's perform the kinetic energy for photon, which is have a photon given of 2.652 times 10 negative 28 kilogram meter per second. We need to convert it. So we have the 3.86 times 10 raised to negative 26 joules. So we have the speed of light, which is constant, 3 times 10 raised to 8 meter per second. So the formula is energy for photon is equal to photon times speed of light. So to perform this, convert 2.652 times 10 raised to 28 kilogram meter per second times 3 times 10 raised to 8 meter per second. So the answer is 7.96 times 10 raised to 20 joules. So we need to find the ratio of these two. So E energy is equal to 7.96 times 10 raised to negative 20 over the 3.86 times 10 raised to negative 26. So the final answer is 2.006 times 10 raised to negative 2 positive 6. It is our final answer.
Always take note that even a massless particle like photon, a particle of light, have momentum, and a more massive particle with the same momentum would have an even smaller velocity. The fact that it takes far less energy to give an electron the same momentum as photon. So, this is the end of my presentation. Thank you for listening.